Hello and welcome to this first video in section 13.5. Here we're going to talk about the chain rule for multivariable functions. So to start, let's look at the chain rule for Calc 1, right? The single variable chain rule. So here we have, say, some quantity y, and it depends on a quantity u, and then u depends on a quantity x. Like let's say, we're going up in a hot air balloon and y represents the temperature of the surrounding air. Okay, the temperature, say, depends on u, which maybe measures our altitude. Okay, but then since the altitude changes with respect to time, x, right, through composition, our temperature will depend on time. Okay, and if I want to understand how all this connects through, say, rates, what I can do is look at, say, the rate of change dy du and the rate of change of u with respect to x, so that'd be du dx. So this would be, right, the rate at which our our temperature changes with respect to altitude, and then this bottom rate would be how our altitude changes with respect to time. So if I wanted to know, say, how does y change with respect to x, so in other words dy dx, what the Calc 1 chain rule says is that this derivative, dy dx, is simply the product of these two intermediate rates. Okay, so in other words, dy dx is equal to the product of dy du and du dx. All right, great. And we can see here, from just thinking in terms of units, right, that, dy du might have units of, say, degrees Celsius per meter, okay? But then this rate would have units of something like meter per second. And when you multiply these two, right, the units, the du portions, are going to cancel out, leaving us, right, with the appropriate units for dy dx, right? Du cancels out, you're just left with that dy dx portion, okay? So now, how about for multivariable functions? So for calculus 4, okay, here we're looking at something like z now, and it depends on two quantities, say x and y. But maybe these then depend on another quantity we'll call t. Okay, so maybe something like, volume depends on the radius and the height, and the radius and the height change over time. So in turn, our volume will change over time through composition. And if I want to know some things about rates of change, then I should look at these intermediate derivatives, okay? So now if I want to measure, say, how does z change with respect to x, right? Since z is a multivariable function, this is really a partial derivative, right? Del z del x, not dz dx. Down below, though, how does x change with respect to time? Well, here, x is a single variable function. So this would be dx dt. Okay. Now, likewise, for the y derivatives, right, z changes with respect to y as del z del y, and y is a single variable function of t, so that would be dy dt. Okay. So now, if I want to know how does z change with respect to t, in other words, dz dt, and notice this is not a partial derivative. Why? Well, because through this composition, okay, z, say the volume or whatever it represents, it'll depend only on, right, this bottom variable, t, okay? So this is going to be what? Well, this new chain rule says you still take products of rates, but what we're going to do is look at, say, how does z change with respect to t in the x direction, and that would be the product of del z del x and dx dt. Okay, and then what we're going to do is look at how z changes with respect to t in the y direction, and that's going to be the product of these rates in green, the y derivatives here. And then the chain rule says we take their sum, and that's going to give us the total change in z with respect to t. Okay, and again, you can kind of see this cancellation here. You know, del x and dx here are in some regard canceling, leaving us with the rate at which z changes with respect to t in the x direction here. So you can kind of think about this as like the, I'll just say the change in the x direction change, and then this one here is the y direction. Okay, cool. So let's go ahead and see this thing now in action. Okay, so for that, we'll go ahead and bring up question number 1. Z is f of xy, which is x times sine y. And then we're given that x of t is t squared and y of t is 2t plus 1. Okay, so part A, right, it says, look, you know, that chain rule thing you just talked about, that's great and all, but really all we need to do is just plug in t squared for x and 2t plus 1 for y. And by doing so, we're really just going to get z as a function of t alone. So here's what I'm saying. I'm saying z can be written as f of x of t, comma y of t. So just substitute these in, we're going to get t squared times the sine 2t plus 1. Okay, so this really now is just a calc 1 derivative, right? Z depends only on the variable t, so I'm going to compute dz dt as what? Well, here I will need to use the product rule because I have the product of t squared and the sine term. So to do that, I'm just going to do the derivative of the first, that's 2t times the sine of 2t plus 1 plus t squared times the cosine of 2t plus 1. Now taking the derivative of the second term, multiplied by the derivative of what's inside from the chain rule, and I'm going to get 2. All right, and then I go ahead and just factor out, in this case 2t is common, so that'll leave us with the sine of 2t plus 1 plus, and I factor the 2 and a t out, so I'm left with a t here and the cosine term. All right, great. So yeah, this really did not require multivariable calculus whatsoever. Okay, so this is definitely a way to solve it. Well, let's now go ahead and solve the same problem, but where we use this new chain rule. Okay, so here I've just copied that diagram from before down for our reference. And so here's what I'm going to do. I'm going to go ahead and do dz dt is equal to the product of these blue rates. So del z del x times dx dt plus the product of these green rates. So del z del y times dy dt. Okay, so let's check out what all of this is. Well, what is del z del x, right? This is my original function in terms of x and y. If I differentiate this with respect to x, I'm just going to get the sine of y, right? Because the derivative of x is 1. So this would be the sine of y times dx dt, which is just 2t. Okay, so again, these, right, are just the product of those blue rates, and that is that expression right there. Okay, so now we're going to add to this, well, del z del y, so that's going to be what? X times the cosine of y, and then I'm going to multiply that by dy dt, and that's just going to be 2. Okay, So you might say, well, wait a minute. This doesn't really look like that answer we got just a few moments ago, right? So although it might not look like it now, right, notice y really is the 2t plus 1 and x is the t squared. So if I now go ahead and convert everything in terms of time, here's what I'll get. I'll get the sine of 2t plus 1 times 2t plus x, which is t squared, cosine of 2t plus 1. Okay, yeah, this is now looking a little familiar. So if I factor out that 2t, yes, I do get exactly the same thing. Okay. Oh, factored that 2 out. All right, so they do agree, and this is a good place to stop. I'll see you next time.